Hello friends, today we are going to see the matrix chain multiplication problem. This is a dynamic programming problem, and in this problem we are going to find out the cost for multiplication of a chain of matrices. So before going to the problem, you have to first understand the rules of matrix multiplication and the method of how to find out the cost of matrix multiplication. Okay, so let's see. So the first rule is, see, for matrix multiplication, number of columns in first matrix is equal to number of rows in second matrix. So let's see what it is. Here A is multiplied with B. So A into B gives you this matrix. Okay. Now see, the first row and the first column cell means 1 1. So this is the cell. Now this answer value comes by multiplying the first row of A with the first column of B. So the first row of first matrix into the first column of second matrix, that is 1 1. Now 1 2, this is the second column. So 1 2, so this cell value comes by multiplying the first row of A with second column of B. Okay, so this is the value. Then 1 3, this value comes by multiplying the first row of A with the third column of B. And 1 4, this value comes by multiplying the first row with the fourth column of B. So that means if we multiply the second row of A with the first column of B, it will give us this value, that is 2 1, then 2 2 2 3, respectively multiplying the second column, third column and fourth column of B. So as you can observe here, for the value of 1 1, means for this value, we have multiplied the first row with the first column of B. So when we multiply, you can see here AP plus BU plus CT means we multiply each element in that row with each element in the column, right? That means for multiplication, the number of elements in this row should be equal to the number of elements in this column. Means the number of elements in the row of A should be equal to the number of elements in the column of B. Okay. So obviously you can see here, number of elements means the number of columns. Number of elements in a row means the number of columns, because as the number of columns is 3 here, that's why the number of elements is equal to 3 in this row. So that is n, means number of columns in first matrix is equal to the number of elements in the first column, means the number of rows. See, the number of elements in a column is equal to the number of rows. Here in this column there are 3 elements, that means there are 3 rows in this matrix. Okay, now so that is the, here I will write, that is n for the second matrix. Now this is the number of columns in first matrix is equal to the number of rows in second matrix, right? So that is the first rule. Then only multiplication can take place. Now the second rule, see, a m cross n matrix multiplied with n cross k gives you a matrix with dimension m cross k. Okay, see, means the answer matrix will be m cross k. Okay, you can see it here. See, we have multiplied these two matrices and we have got this m cross k matrix, means 3 cross 4 matrix. Okay, 3 rows and 4 columns, right? Now the third rule, how to find out the cost. See, So for finding out the cost, you have to find out the number of multiplications taking place. So see, for one sale, how many multiplications take place? 3 multiplications here. What is the meaning of 3 multiplications? It is equal to n. See, it is equal to n. N multiplications take place for one sale, because there are n elements in the row of first matrix multiplying with the n elements in the column of second matrix. Okay, so that's why n multiplications take place for one cell. And how many such cells are there? M cross k cells are there. So for each cell n multiplications take place. So m cross k cross n. These are the number of multiplications taking place. So I have written it here, m cross n cross k. I have written it in this way because it will be easy to understand like this. If m cross n matrix multiplies with n cross k matrix, then see, m cross the common n into k. This is the cost. M cross the common n cross k. This is the cost. Now as we have understood the rules for matrix multiplication, let's go and solve the problem. So if you have been given 5 matrices, that is A0, A1, A2, A3 and A4, and these are the sizes of those matrices. So A0 matrix is of size 3 cross 4, then A1 is of size 4 cross 5, that is m cross n. Okay, and similarly for A2, A3 and A4, the sizes are 5 cross 6, 6 cross 2 and 2 cross 5 respectively. So here I have mentioned 2 ways to multiply these matrices. So see, suppose the first way is, first we multiply A0 and A1, then to the result of that multiplication we multiply A2, then to this result we multiply A3, and again we multiply A4. So let's start the multiplication. So first A0 into A1 means 3 by 4 into 4 by 5. So as you know, we say this as m by n into n by k, like mentioned here. See, m by n into n by k. So what is the result matrix size? That is m by k. See, 3 by 4 into 4 by 5. So the result will be 3 by 5. So that is the result here, 3 by 5. Now what is this? See, this is the cost of multiplication. Like written here, if we multiply m cross n with n cross k, then the cost of multiplication is m into n into k, right? M into the common n into k. So here the cost of multiplication will be m into n into k, means 3 into 4 into 5. Okay, that is the cost. Now as the result size of multiplication A0 into A1 is 3 by 5, now we have to multiply A2 to this result. So I have taken A2 here. So what is the size of A2? That is 5 by 6. So it is here. What will be the cost of multiplication? 3 into 5 into 6. And what is the result? See, 3 by 6, because m, n and n, k. So the result will be m by k. So that is here. So 3 by 6. And the cost is 3 into 5 into 6. Again A3 comes here to multiply the result of this multiplication. So the result is this. So 3 by 6 into 6 by 2. So the cost will be 3 into 6 into 2 and the result will be 3 by 2. So it is written here. Again let's multiply that result by A4. So 3 by 2 into 2 by 5. So the cost will be 3 into 2 into 5 and the result will be 3 by 5. Okay. So let's calculate the total cost. See, 3 into 4 into 5 is 60. 3 into 5 into 6 is 90. 3 into 6 into 2 is 36 and 3 into 2 into 5 is 30. So let's add them. Okay. So 60 plus 90 is 150 plus 36 is 186 plus 30. So that is equal to 216. So there are total 216 multiplications taking place when we multiply these 5 matrices in this way. Okay. Now let's see the another way. So suppose you multiply A0 and A1 first. Parallelly you multiply A2 and A3. Then you multiply their results with each other. And then to this result you multiply A4. Okay. So let's see how it is done. See, A0 into A1 means 3 by 4 into 4 by 5. So the cost is 3 into 4 into 5 and the result is 3 by 5. Now A2 into A3 means 5 by 6 into 6 by 2. So the cost is 5 into 6 into 2 and the result will be 5 by 2. See, this is A0 into A1 and this is A2 into A3. Now you have to multiply these two, right? So 3 by 5 into 5 by 2. So the cost is 3 into 5 into 2 and the result will be 3 by 2. Okay. Now this is 3 by 2 is the result. Now this result should be multiplied with A4, right? So 3 by 2 into 2 by 5. So the cost will be 3 into 2 into 5 and the result will be 3 by 5 here. Okay. So let's see what is the total cost. So 3 into 4 into 5. So it is 60 and here 5 into 6 into 2, this is also 60. Okay. Then 3 into 5 into 2, this is 30 and 3 into 2 into 5, this is also 30. So what is the total? See, 60 plus 60 is 120 plus 30 is 150 plus 30 is 180. So 180 is the total cost. Okay. So see here, the cost of multiplication in this way and in this way are different. See, but the answer of multiplication will be same. Means the answer matrix of this whole multiplication, whatever will be the resultant matrix, that answer will be same for both processes. Only because we multiply them in a different way, the cost will be different. Similar to the multiplication operation of numbers like A into B into C. Even if you multiply B into C first and then you multiply A, or you multiply A into B first and then you multiply with C, the answer will be same. So same is the case here. The result will be same. But in case of matrix multiplication, the cost will be different. Okay. And we have to find out the minimum cost and that way in which the cost is minimum. So there is a possibility that some other way may give a cost which is less than 180. Okay. So that way will be efficient. Our problem statement is to find out the minimum cost of a matrix chain multiplication. And we are going to use dynamic programming now to find out that minimum cost. So for dynamic programming, we always start from smaller subproblems and then we go towards the bigger subproblems. So here, see, first we have to solve for L equal to 0. Means there are 0 multiplications. That means there is only an individual matrix. See, this is the base condition for our memoization matrix. Then L equal to 1. That means there is one multiplication, which in another word means a group of two matrices. Okay, means if there are two matrices, then there will be one multiplication. Then we will go for L equal to 2. That means a group of three matrices. Okay, and similarly we go up to L equal to 4, means a group of 5 matrices. That is our final size. Okay, so when L is equal to 0, that means the individual matrix, So I represents the starting of the group and J represents the ending of the group. If that is an individual matrix, obviously starting is 0, ending is 0 for the first cell, means A0. See, if there is no multiplication, then the cost will be 0. Then I equal to 1, J equal to 1, this cell, okay, for the individual matrix. So 1, 1 means A1, okay, and again the cost will be 0 because there is only one matrix we have considered, that is A1, and there is no multiplication, so the cost is 0. 2, 2, that is A2, means the cost is 0. 3, 3, that is A3, cost is 0, and similarly for 4, 4, that is A4 and the cost is 0. Now let's go to L equal to 1, means a group of 2 matrices. See, we are going to fill in a diagonal way. These are the diagonals, okay. Just remember, we are going to fill the values in a diagonal way. Now 0, 1, see, 0, 1 means A0, A1, okay, means a group of 2. Now if there is a group of 2, then we have only one possibility, that is multiplying those 2 matrices. We can only multiply in one way, that is A0 into A1. So A0, A1 means 3 into 4 into 5. So what is the cost? 3 into 4 is 12, 12 into 5 is 60. So 60 is the cost. Now another group of 2 is A1, A2, okay, means A1, A2. So 4 into 5 into 6. So 4 into 5 is 20, 20 into 6 is 120. So 120 is the cost. Now the third group is A2, A3. Okay, so A2, A3. See here. 5 into 6 is 30, 30 into 2 is 60. And the last group is A3, A4. So A3, A4 means 6 into 2 is 12, 12 into 5 is 60. Yes, we have calculated the cost for L equal to 1, means a group of size 2. Now let's go to a group of size 3, means L equal to 2. Okay, so what is the first group of size 3? That is A0, A1 and A2. Means I is 0 and J is 2. So 0, 2 means this is the cell, 0 and 2. So this is the cell. Now here is the twist. For a group of size 3, means if it is A0, A1 and A2, we cannot directly write the cost of multiplying these 3, because there are 2 possibilities to multiply A0, A1 and A2, and I have written the possibilities here. Now let's see. See, the first possibility is that we keep A0 as it is and we multiply A1, A2, okay, and after we multiply A1, A2, we multiply A0 to the result of A1, A2. And the second possibility is that first you multiply A0, A1 and then you multiply A2 to the result. Okay, so these are the 2 ways in which we can multiply A0, A1 and A2, right? So for the group of size 3, means for L equal to 2, as we know there are 3 cases, means for a group of size 3 there are 3 groups, means A0, A1, A2, A1, A2, A3 and A2, A3, A4. Inside one group, inside this group, there are 2 possibilities. Similarly, inside this group also there are 2 possibilities, and inside this group there are 2 possibilities. Now let's first concentrate on this group, how to find out the cost of those 2 possibilities. As you can observe here, see, first I have separated A0 and I have written A1 and A2 in the bracket. After that I have written A0, A1 in the bracket and I have separated A2. Means there is a partition point. See what I am saying? There is a partition point. And that partition point is K. That is K. Okay. So what is that K? So this is the formula. Right? This is the formula for that partition and finding out the cost of the partition. See, M of ij means here I is equal to 0 and j is equal to 2. For A0, A1, A2, I is 0 and j is 2 is equal to M of ik, because k is the partition point from where we are dividing the group. That is the partition point. So for k is equal to 0 here, see, M of I is 0 and k is 0. Means M of 0, 0. So let's see in the matrix, this is the matrix M, M of 0, 0. That means A0. Okay. So A0 is separated. Okay. Plus, see, this is the cost for A0 plus M of k plus 1 to j. As k is 0, 0 plus 1 is 1 and j is 2. Okay, j is 2. So M of 1, 2 means 1, 2 means this cell, which tells us the cost for A1, A2. Okay, so that is here A1, A2 means the first partition contains only A0 and the second partition contains A1, A2. Okay, in this way we found out our first partition. So that is here. See, A0 and the second partition is A1, A2. If you want, you can give bracket to A0 also, means this is one partition, this is second partition. Now, how to find out the cost? See, we know the cost. We have memorized the cost for 0, 0, 0, 0 and that cost is 0. Okay, so for A0 the cost is 0 plus for A1, A2 also we have memorized the cost. That is what the dynamic programming is all about. We are memorizing the values. Means when we are going for L equal to 2, we are making use of the values for L equal to 1 and L equal to 0. We are using these values which we have memorized inside this memorization table. So 1, 2. So what is the value for 1, 2? That is 120. Means it is 120 here. So 0 plus 120. Now the third part in the formula is this. And I will explain this formula here. Now see, what is the dimension of A0? It is 3 by 4. And what is the dimension of A1 and A2? It is 4 by 5 and 5 by 6. So see here, as this is an individual matrix, we don't need to solve. Now A1, A2. So here, if we solve this, you can see 4 by 5 into 5 by 6, the result dimension will be 4 by 6. Now, as both brackets are solved, now the results are here for the two brackets. Now a final multiplication has to be performed between these two matrices of size 3 by 4 and 4 by 6. So here is the extra cost, means here is this extra cost for the multiplication of these results. What I mean to say is that we have already memorized the minimum cost for these two problems. See, 0, 0 is 0 and 1, 2 is 120. Okay, 1, 2 is 120. So we don't solve these problems. We directly concentrate on the results here, 3 by 4 and 4 by 6. See, this result 3 by 4 and 4 by 6, this dimension is not given to us. or we have not memorized this dimension. Okay, so how will we find out the final cost of the multiplication of these two matrices? We have only memorized the costs, we have not memorized the dimensions. Okay, so we have to find out some way of figuring out those dimensions to multiply, just for finding out that extra cost, this cost. So now, as 3 is P0, we can say that P0 is the first dimension of first partition, because see, Pi and I is 0, okay, and J is 2 here. So as I is 0, okay, that means that is the first matrix in the first partition. Okay, so you can say that it is P0, means it is Pi, which is written here. Okay, now the second P1 means Pk plus 1. See, what is K? K is 0. K is 0. Okay, and Pk plus 1 is P1, so that is 4. Yes, so 4 is P1. So we can say that it is first dimension in second partition. See, in the second partition, what are the dimensions? 4, 5, that is common, and 6, means P1, P2 and P3. So what is P1? See, it is the first dimension in the second partition. This is the second partition, and P1 is the first dimension in this second partition out of P1, P2 and P3. That is what I have written here. Okay, and P3 is the last dimension in this second partition. P3 is the last dimension in second partition. So 3 into 4 into 6. So 3 4s are 12, 12 6s are 72. So that means 120 plus 72. So that is equal to 192 is the total. Now when k equal to 1. So what is the meaning of k equal to 1? Means the partition is the first matrix, means A0, A1 will come in one partition and the remaining A2 will go in another partition. That is k equal to 1. This is the partition point. Okay. Now for this, let's start 0 to 1. 0 to 1, that is 60. Cost of A0, A1 is 60. Cost of 2 means 2, 2, that is individual. So that is 0. And finally plus Pi into Pk plus 1 into Pj plus 1. So see, now what is the partition? That is A0 into A1 is the first partition and A2 is the second partition. So Pi means the first dimension, that is 3. Okay, that is P0. Then Pk plus 1 means the first dimension in the second partition. So what is the first dimension in the second partition? That is P2, that is 5. Okay, so that is Pk plus 1, and Pj plus 1 is the last dimension in the group. What is the last dimension? That is 6. 3 into 5 into 6 means 90. So 90 plus 60 is 150. So 150 is the total cost for k equal to 1. Now what is minimum? Obviously, which method we will prefer? We will prefer the second method for k equal to 1. Means we will multiply in this way. Okay. So 150 is the cost for this method. So let's write it here. For 0 to 2, 150 is the cost. And one more important point here. See, for calculating 150, what is the partition point? That partition point is k is equal to 1. Okay. So you have to store k equal to 1 here. This helps us to know how is the partition for this group. For 0 to 2, what is the partition point. You have to memorize that partition point so that when you go in reverse, you can understand in what way we have multiplied these matrices. You can find out that arrangement of matrices. Okay, and now this formula. See, m of ij is equal to 0 if I equal to j. See, if I is equal to j, then obviously that is 0. But if I is not equal to j, then it is minimum of, see, here what we did, we took the minimum that is written in this formula. Minimum of whatever is the partition point. See, k ranges from I to j, means if I is 0 and j is 2, k was having two values. See, 0 and 1. 0, 1. So it ranges from 0 to 2. K is less than j, means k cannot be 2. So the last matrix cannot be the partition point. It will only go from 0 to 2, means it will take values 0 and 1. And we will take minimum of those two partition point costs. This is the same thing as you have seen here. Only extra thing written here is we are going to take minimum cost of all the partition points, that is written in this formula. This is our final formula for every cell. This formula works for every cell. Now here I tell you why I have not filled values in these cells. See, why no values in these cells? Because I is less than j in our formula. But here, see, 1 is greater than 0. See, I is greater than 0. So I have not filled the values because we are not capable of multiplying the matrices in reverse. See, if you go for 1 0, 1 0 means what? A1 A0. So can you multiply 4 5 and 3 4, means A1 A0, 4 5 and 3 4. See, number of columns should be equal to the number of rows as you have studied the condition for matrix multiplication, but they are not equal here. So for all i's which are greater than j, you cannot fill the values because these cells do not satisfy the condition of matrix multiplication. Okay, let's go ahead. So the second case is A1, A2, A3, means I equal to 1 and j equal to 3. So the second group is A1, A2, A3. So here if partition point is 1, means A1 will be separate and A2, A3. Okay. Now what is the cost for A1, means 1 1, that cost is 0. Okay, plus the cost for A2 A3 means 2 3, so that cost is 60. Okay, plus the multiplication of the results, that is the cost for multiplication is pi into pk plus 1 into pj plus 1, means the first dimension of the first partition, that is 4. This is the first dimension. Then the first dimension of the second partition is 5, 4 into 5 into the last dimension, that is 2. Okay, so see, 4 into 5 is 20, 20 into 2 is 40. So 40 plus 60 is 100. Okay, so 100 is the cost for this partitioning method. Now, if k equal to 2, then what will be the partition? See, A1, A2 and A3. So this is the partition for k equal to 2 because the second matrix is the partition point. So let's do it here. A1, A2 and A3. Okay, so what is the cost for A1, A2? See here, 1 2, so that cost is 120. Okay, plus what is the cost for A3? See, 3 3, so that cost is 0. Plus see the multiplication of the results, the cost for that multiplication is here. See, P1, that is the first dimension of the first partition. So P1, that is 4 into, what is the second partition? A3 is the second partition. What is the first dimension of second partition? That is 6 into the last dimension in this group, or you can say the last dimension of the second partition. So that is 2. So 4 into 6 into 2. So let's add. So 120 plus 4 into 6 is 24 into 2 is 48. So that is 120 plus 48 is 168. Okay. So what is minimum? See, 100 is minimum. Means k equal to 1. So this partition is giving us the minimum cost. So we write 100 as the minimum cost for 1 to 3 and k equal to 1 is the partition. Now let's go for the third case, that is A2, A3 and A4. See, for L equal to 2, these are the three cases, and now we are at the third case, that is A2, A3 and A4. So the first thing is the partition point is 2. See, the partition point ranges from I to j. As it is A2 to A4, so I is 2 and j is 4. So k will take values 2 and 3. Okay. So the first value is 2. So what will be the partition for k equal to 2? See here, for A2, A3, A4, if k is equal to 2, means this is one partition and A3, A4 is another partition. Okay. So what will be the cost for that? For the partition A2 and A3, A4 as the second partition. Okay. Now what is the cost for A2? See here, for A2, 2, so that is 0, plus A3, A4. So what is for 3, 4? That is 60. So 60 is the cost, plus this factor. So you know now how to calculate this. See, the first dimension of the first partition is our Pi, that is P2. So it is 5 into the first dimension in the second partition, that is 6, and the last dimension in the second partition, that is 5. Okay. So let's add them. 5 into 6 is 30, into 5 is 150. 150 plus 60 is 210. Let's go for partition point k equal to 3. So that partition is A2, A3 and then A4. Okay. As 3 is the partition point, from A2 to A3 there will be one partition and A4 will be another partition. Now 2 to 3, what is the cost? 2 to 3, that is 60, plus 4, that is 0, plus, see, for A2 to A3 is one partition and A4 is another partition. So what is the first dimension in the first partition? That is 5, into what is the first dimension in the second partition? That is 2, into what is the last dimension in the second partition? Is 5. So 5 into 2 into 5. So 5 into 2 is 10, into 5 is 50. So 50 plus 60 is 110. Okay. So what is minimum? 110 is minimum. So I write here 110 for 2 to 4 and k is equal to 3. Right? Yes. So this is over for L is equal to 2. Means a group of size 3. Right. Now we will make use of these three values, means these values for the group of 1, 2 and 3, and we will calculate value for the group of 4 now for L equal to 3. So let's go for L equal to 3 now. Now for L equal to 3, the first group is A0, A1, A2, A3. So here it is A0, A1, A2 and A3. And the second group is A1, A2, A3, A4, which is written here. See, A1, A2, A3 and A4. So these are the two groups for L equal to 3, means the group of size 4. Now, for the first group, suppose the partition point is 0, means K is equal to 0. So, two partitions will be A0 and A1, A2, A3. So, these are the two partitions. Now, let's calculate the cost. See, for 0, 0, the cost is 0 plus A1 to A3 means 1 to 3. So that is 100. The cost is 100 plus this factor. So see, what is the first partition? First partition is A0 and the second partition is A1, A2, A3. So these are the two partitions. So the first dimension in the first partition is 3 into the first dimension in the second partition is 4 into the last dimension in the second partition is 2. Okay, so 0 plus 100 plus 3 into 4 is 12, 12 into 2 is 24. So the total is 124. Okay, now let's go for partition K equal to 1. Now, if K equal to 1 is the partition, means A1 is the partition point. So, A0, A1 in one group and A2, A3 in another group. Right? Now, what is A0, A1 cost? See, 0 to 1 means 60 is the cost. Plus, what is A2, A3 cost? A2, A3. So again that cost is also 60 plus this factor. So A0, A1 and A2, A3 are the two partitions. So A0, A1 and A2, A3. So what is the first dimension in the first partition? That is 3, which is Pi. Then what is the first dimension in the second partition? Here it is 5. That is Pk plus 1. And what is the last dimension in the second partition? That is 2. That is Pj plus 1. So, into 2. So, 60 plus 60 is 120 plus 3 into 5 is 15 into 2 is 30. So, 120 plus 30 is 150. Right? Now, see here, if we take K equal to 2 as the partition point, see, here there are 3 partition points because I is 0 and J is 3. So K ranges from 0 to 3 means K will take values 0, 1 and 2. Okay, because K is less than 3. So values will be 0, 1 and 2. So now the partition point 2. So for K equal to 2, the partitions are, see here, A0, A1, A2 and A3 is the last partition. Okay. So now, what is the cost for 0 to 2? 0 to 2, the cost is 150. Plus, what is the cost for A3? That is an individual matrix, so the cost is 0. Plus, see, these are the two partitions. A0 to A2 is one partition and A3 is another partition. So, the first dimension in the first partition is 3, which is Pi, into the first dimension in the last partition is 6, which is Pk plus 1, into the last dimension in the second partition is 2. So, that is 2, which is Pj plus 1. So, 3 into 6 into 2. Okay. So, 3 into 6 is 18 into 2 is 36 plus 150. So, the total cost is 186. Right. So, what is minimum? 124, 150 and 186. So, 124 is minimum, means K equal to 0 is the optimal partition point. So, 124 is the cost for 0 to 3, means A0 to A3 for that group, for this group. and k equal to 0 is the partition point. Okay. So now let's go for the second group. For L equal to 3, the second group is A1, A2, A3 and A4. Now if k equal to 1 is the partition point, what will be the partition? See, the partition will be from A1 to A1 and now A2 to A4 will be the second partition for k equal to 1. See, A1 and A2, A3, A4. So what is the cost for A1? That is an individual matrix. So 0 plus 2 to 4, 2 to 4. So that is 110 plus C. First dimension of the first partition is 4 into first dimension of the second partition is 5 into the last dimension of second partition is 5. 4 into 5 into 5. So 4 into 5 is 20, 20 into 5 is 100, 100 plus 110 is 210. So 210 is the total cost. Now for k equal to 2, what will be the partition? See, A1, A2 and A3, A4. These are the two partitions. Okay. Now see, for 1 to 2, 120 is the cost. Plus for 3 to 4, 60 is the cost. Okay. Plus see, what are the two partitions? A1, A2 and A3, A4. So the first dimension of the first partition is 4 into the first dimension of the second partition is 6 into the last dimension of the second partition is 5. 120 plus 60 is 180 plus see, 4 into 6 is 24 into 5 is 120. So 180 plus 120. So that is equal to 300. Now for k equal to 3, let's see what are the partitions. See, A1, A2, A3 and A4. Okay. Now what is the cost for A1 to A3? A1 to A3, that is 100. So 100 is the cost. Plus for A4, 0 will be the cost because that is an individual matrix. Now plus see, what is the division? A1 to A3 and A4. First dimension of the first partition, that is 4. Then first dimension of second partition, that is 2. And last dimension of second partition, that is 5. So see, 100 plus 4 into 2 is 8. 8 into 5 is 40. So 140. 140 is the total cost for k equal to 3. Means out of 210, 300 and 140, what is minimum? 140 is the minimum. So k equal to 3 is the partition point. And for 1 to 4, means for A1 to A4, C, 140 is the cost and k equal to 3 is the partition point. Now let's go to the final cell, that is 0 to 4, means all the matrices. Okay. So let's see for 0 to 4. So for L equal to 5, I is 0 and J is 4. Okay. So the first partition point is 0. It will go from 0 to 4, means now k will take values 0, 1, 2 and 3. Okay. Now for k equal to 0, what will be the partition? See, A0 is one partition and the second partition is A1, A2, A3 and A4. Okay. Let's calculate the cost. For A0, 0 is the cost. For A1 to A4, 1 to 4, that is 140 is the cost, plus this factor. So that is, see, what is the partition? A0 is one partition and A1, A2, A3, 4 is the second partition. So the first dimension of the first partition is 3 into the first dimension of the second partition is 4 into the last dimension of the second partition, that is 5. Okay. So 3 into 4 into 5. So 3 into 4 is 12, 12 into 5 is 60. 140 plus 60 is 200 is the total cost. Now for k equal to 1, see A0, A1 is one partition and A2, A3, A4 is second partition. Okay. Because 1 is the partition point, A0 and A1 will be the one partition, and from k plus 1 means from A2 to A4 is the second partition. Now for 0 to 1, 60 is the cost, plus A2 to A4, 2 to 4, 110 is the cost, plus now see, you have to calculate the cost for multiplication of the results of these two sub problems. So what are the sub problems? A0 to A1, this is the first partition, and A2, A3, A4 is the second partition. So first dimension of the first partition is 3, first dimension of the second partition is 5 into the last dimension of the second partition is 5. Okay, so 3 into 5 is 15, into 5 is 75, 75 plus 110 is 185, 185 plus 60 is 245. Okay, now let's go for k equal to 2. So the partition is A0, A1, A2 and A3, A4. Okay, now from 0 to 2, 150 is the cost, plus 3 to 4, 60 is the cost, plus C, 0 to 2 is one partition for this, and 3 to 4 is another partition. So first dimension of the first partition is 3 into first dimension of second partition is 6 into last dimension of the second partition is 5. So 3 into 6 is 18, 18 into 5 is 90, 90 plus 60 is 150, 150 plus 150 is 300 is the cost for k equal to 2. Now for k equal to 3, let's see A0, A1, A2, A3 and A4 is the second partition. So for 0 to 3, 124 is the cost, then plus for A4, see 0 is the cost, plus now see what is the partition, A0 to A3 and A4 is the second partition. Okay, now first dimension of the first partition, that is 3 into first dimension of second partition, that is 2 into last dimension of second partition, that is 5. Okay, so 3 into 2 into 5. So 3 into 2 is 6, 6 into 5 is 30. So 30 plus 124 is 154. So what is minimum? 154 is minimum. Means k equal to 3 is the partition point and 154 is the minimum cost. So here I write 154 and k equal to 3 as the partition point. Okay, so the minimum cost for multiplication of 0 to 4, the matrices A0, A1, A2, A3 and A4 is 154. Now how to trace back, means how to find out that arrangement of matrices, that arrangement of brackets. So let's see that. So see, this is very simple. You have to start at the end, means the last cell in which we got the cost for 0 to 4. Okay, now 154 is the cost and partition point is 3. Means for these 4 matrices, the partition point is 3. So get the partition done. Okay, now you have to see in this bracket there cannot be further partition. Now what will be the partition in this bracket? Okay, for 0 to 3, see for 0 to 3, here 124 is the minimum cost, but partition is k equal to 0. So for k equal to 0, let's make the partition C. A0 is one partition and A1, A2, A3 is another partition. Okay, inside this partition, this is the partition. So I will write it again here. See, A0, A1, A2, A3. This is 1 and A4. Okay, now inside check. There can be partition in A1 to A3. So 1 to 3. What is the partition? K equal to 1 is the partition. That means see, A1 is one partition and A2, A3 is another partition. Right? Now there cannot be further partition. So I will write it here. See, A0 into A1 into A2, A3. Okay, this is 1, and to the whole you multiply with A4. Okay, so that is the partition, and that is the arrangement of brackets. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.